Hi there. So now we're on section 2.3, elements and compounds. So elements and compounds can be put together in a group called pure substances. So we've talked about how all matter can be divided into mixtures and pure substances. And if you look at the doodle notes here, right, we have talking about what are the two principal ways that we can classify matter. And so the first way that we classify matter is classify matter is between what state it's in, solid, liquid, or gas, and then also what is it composed of, meaning pure substance, which could be elements and compounds, or mixtures. And those first two, elements and compounds, those are good examples of pure substances. And we'll see why they can be considered pure substances when we look at the particle diagrams on the right. So let's talk about what is an element. So an element is going to consist of only one type of atom. How do we classify what makes an atom of one type than another? We're going to learn that in a few more chapters, but basically it's the number of protons that are in it. So it has to consist of one type of atom and cannot be broken down by either chemical or physical means. That in order to break down an atom, that would be like a nuclear reaction to break it up into its component protons, neutrons, and electrons. And elements can exist as either atoms or molecules. Something like the metals, iron, nickel, but even like sodium, uranium, calcium, those exist as atoms, but a lot of the nonmetals actually exist as molecules. So oxygen in the air we know is O2. You've learned that in biology. And if you look at the particle diagram for these over on the right-hand side, you can see in the upper left-hand corner, I always put some examples of what symbols we would use for elements. And so that would just be the elements symbol from the periodic table. But for some of those nonmetals that exist as molecules, you can see there's two atoms bonded together. So that's why you would see O and then a subscript 2, or F and then a subscript 2 for oxygen gas or fluorine gas. And if you look at the diagrams in the other three boxes, you can see everything in those boxes is just one type of particle. It may be a single atom like the green circles or a molecule like the two blue. But if we look at compounds, we're going to see something different. So how are compounds different? Well, they're atoms compounds contain atoms of two or more different elements that need to be bonded together in a very specific ratio. They can be broken down into simpler substances, which would then be the elements, but they would have to be broken down by chemical means, not physical means. So not filtration, distillation, chromatography that we learned about earlier. The individual compound is going to have very different properties than the elements that make it up. And if you take a look at the diagram on the right, you can see in the upper left-hand box, we have the chemical symbols for compounds. Sometimes you can have subscripts or you cannot have subscripts, depends on how many atoms of that element there are in the compound. And the subscript refers to the element that comes before. So H2O means 2 hydrogen and 1 oxygen. And you can see in the other particulate diagrams, you can see that there are, these two circles. There's a green circle and a red circle. And those are the two different elements. They're bonded together. They're always in the same ratio. But in that box, it's only one type of molecule or only one particle of that compound. That's what makes the difference between a compound and what is next, which are mixtures. And we talked a lot about the different types of mixtures in another video, but we know mixtures, they have to contain two or more substances, and those substances could be elements or compounds themselves. And those substances are not bonded to each other like they would be in a compound. They can be separated physically, and we went through the distillation, chromatography, and filtration, and they do retain some properties of the original components, right? Muddy water has properties of mud and water, but they're mixed together. And if you look at the picture over on the right, you can see there's some examples of mixtures, like salad is a mixture, and air and sugar water. Those are all examples of mixtures. And you can see the pictures here. You see different compounds, and they're not bonded together. So, in the top right, you see maybe two different elements, but they're not bonded together. That could be like an alloy of two different metals. And then in the bottom left picture, you see molecules. Those are water molecules and another element mixed together. And then you can have on the bottom right, you see there's three different components of that mixture. There's different compounds, and then there's also an element in there. Okay, so now there's space on the bottom that is a place for you to try to answer this question. How do you know that water is not simply a mixture of hydrogen and oxygen? Think about how you might separate those two.